Hey, I'm Hannah Mae, and this is my reaction video for Chapter 9, Direct from the Sun, Solar Energy. Basically, this chapter basically just talks about solar energy being a promising resource for our future and how it just comes straight from the sun from like photovoltaic cells and solar thermal systems, and how it offers so much more than just electricity and heating. And we'll talk more about those later. And of course, there's going to be different challenges and things that we'll have to get through before we can fully rely on this, but we'll also talk about that more later. And while there are these challenges, it's becoming more competitive with our leading energy source, which is fossil fuels right now, and it would just help us to be able to change to this more sustainable, climate friendly type of energy source. This first section that we're going to talk about is called the solar resource. In this section, we just learn about like the different distributions and transformations of solar energy and how it's from the core of the sun and it goes to the earth. We talk about solar constants and its variations. Of course, like we said, energy production is from the sun's core, and it causes nuclear fusion and it produces energy and like in a form of gamma rays. We've all heard of that before, most of us anyways. The solar constant is basically just like the Earth's average distance from the sun. That's how I remembered it this week for our vocabulary quiz that we have every Thursday or Friday. Uh, Next, it's like the insolation, which is like the total solar power that is intercepted by Earth if we were like a flat disk facing the sun. So like sun, Earth, this would be us right here. That the interception's like right in the middle. We know that the insolation is higher in places like the tropics. We learned that also this week from this chapter because they're closer to the equator. Which brings me to my first diagram, and I thought this one was important because it just shows us the different ways that solar power or energy can be like distributed in different ways, such as ultraviolet, visible, and infrared. Uh, yeah, I liked it, and how ultraviolet is obviously by far the least way of distribution. This next section is photovoltaic solar energy. And it just talks about how this is a technology that is very promising and efficient, and that uses semiconductors and properties of silicon to turn sunlight into electricity. It's actually really sunny right now. Uh, but we learn about all these different types of photovoltaic cells, like monocrystalline, which is the highest, it has the highest efficiency, polycrystalline, and amorphous silicon PV cells. We also learn how they can be used in solar panels and arrays like PN junctions, series connections, and sun tracking mechanisms. And all these applications are in remote locations, developing areas, lighting systems, scientific facilities, and even transportation. Solar heating is next, and it just talks about how the thermospan systems work in a solar work in hot water solar setups. These just basically make sure that we know about their simplicity and the challenge that it is to place the storage. Like it's a challenge, but like it has to be like the storage tank has to be above the collectors. It might be a challenge, but it's just what is needed in this in these types of setups. These types of systems, they operate with a pump, without a pump actually, and they're more density driven with flow. And like I said, the storage tank has to be above the collectors. This is challenging in most circumstances, so it could be harder to get this done. But in the long run, it's just what it has to be done. Solar domestic hot water systems are actually much more simple, cost effective, and self-contained, which is a huge win in the solar power uh altogether in my book anyways. These systems are very viable and they can work in almost any climate, and It reduced our reliance on fossil fuels in homes and buildings. Which brings me to my next diagram, which is this passive solar house, and it just shows how these are the solar panels up top, and it shows how they use this direct sunlight and the concrete slab to produce its energy. Which is our my next the next section in this chapter was called solar thermal power systems. Basically, this little section basically just talks about how solar power systems work by using the sunlight to achieve these high temperatures. And this can be very efficient, but of course there are challenges like in anything that we go at. And it has actually been ruled economic in some situations compared to other sources of energy. Um, Solar power, these types of systems use this parabolic dish concentrator, and it just focuses on the sunlight and to achieve these high temperatures. And of course, it can produce electricity from heat engines. This also talks about how these dishes can get to high temperatures, which makes them more effective in the converting the solar power into electricity. Of course, there are challenges, and some of these challenges include like mechanisms to track the sun and how, in comparison to other sources, they can be uneconomical, like we just said. Which brings me to my next diagram, which is it just shows a bunch of different solar concentrators, and it just talks about this one's a parabola, this one's a parabolic dish, and this one's a parabolic trough. It's just different parabolas and how they're different solar concentrators. And it just gives me a better understanding of how they work and how electricity is produced through solar power. Next, this one just talks about other solar applications, and this was a smaller section, so I didn't know if I was going to get much from it actually. But it just shows us about different innovative direct applications of solar energy and how it goes way beyond this original power and heating, but it also discusses different uses to help get its point across about how solar power can actually address some of our problems and needs. Solar cooling is actually when they use this to cool from the absorption of refrigeration systems, and it could be used in like developing countries where they don't have much, or less fortunate countries where they don't have consistent power. This would be a good alternative for them. Solar cooking and water purification is when these solar ovens are cooking in sunny climates, and it just helps to reduce deforestation, which is better for our climate and habitats for the animals because we don't want to harm them. And the solar stills actually can evaporate fresh drinking water from the sea, and I never thought that could even be possible. The next thing is these solar ponds. They actually collect the thermal energy for things like heating and processes in industries. Photo Photolysis uses solar power to make hydrogen fuel by breaking this fuel into both oxygen and hydrogen. The next one is environmental impacts. Of course, all different energy sources or anything that you go at is going to have different effects or impacts on the environment as a whole. Actually, solar energy is more environmentally friendly, like we've talked about, but the most difficult thing for us is like land use would be needed in a large scale. And some of the toxic materials would be hard to get across of the disposal of like these photovoltaic cells. Solar power actually releases no pollutants into the atmosphere while during its operation, but the biggest problem, like I said, is the land use. And some of the toxic materials include cadmium and arsenic. Finally, we get to the Science Meets Policy box, and it's called Renewable Portfolio of the Two of a Tale of Two States. And it just talks about like the solar energy and how it's very abundant resource and how it can be promising for our future as a power source, and it has actually become very competitive with our existing reliance with fossil fuels. It's widely available, it's clean, but it can only supply a small percentage of the world's demand for power. The renewable portfolio standard actually is just plays a role in encouraging the adoption of this type of resource, solar energy. I don't think that it's really the best idea just because I feel like solar power really depends on the weather and the region or climate that you're in. So therefore, I don't really think that it would be really smart to just try to full on go to solar power because I don't think it's would be effective for everyone. Thanks. I enjoyed this chapter and learning new things.